Assalamualaikum and hi everyone. In this video, we're gonna discuss about the assignment for SMN 3043, which is assignment 1 that consists of 2 questions. Before that, let's get to know with our group members. Our group consists of 5 members. First one is Nur Husna Hayati binti Muhammad. Second member is Susan Yong Susan. Third member is Dazel Cameron Josh.
Next is Asha Ashakirin binti Asri. And the last one is Muhammad Khairuzami bin Kashmir.
Question 1. Tell us that a metal bar with an initial temperature at 25 degrees Celsius is immersed in a container of boiling water. It was observed that the temperature of the metal bar increased 3 degrees Celsius in 1 minute. So, we need to determine the time required for the metal bar to reach 85 degrees Celsius. So, from there, we got that it is about Newton's law of heating and cooling. So, we use the equation of dt over dt equal to k times t minus tm, where t is the time temperature of a body at any time. Tm is a constant temperature of the surrounding medium, and dt over dt the rate of which the body cools. Next, we arrange the equation where dt for the temperature in the left hand side and dt for the time in the right hand side. So we got dt over t minus tm equal to k dt. Next, we need to integrate both sides, and we get ln t minus tm equal to kt plus c. Next, we multiply by exponent both sides and we get t minus tm equal to e to the power of kt plus c, and we can separate e to the power of kt plus c into e to the power of kt times e to the power of c. So we can assume that e to the power of c as a constant, which is we call it as a. So we get t minus tm equal to e to the power of kt times a. Next, we move tm into the right hand side and left the t into the left hand side, and we got t equal to tm plus a times e to the power of kt. When temperature equal to 25 degrees Celsius, the time is equal to 0, since 25 degrees Celsius is a initial temperature. Then, we substitute into the equation and we get 25 equal to 100 plus a times e to the power of k times 0. Since the metal bar is immersed into the boiling water, so the surrounding temperature for this case is 100 degrees Celsius. E to the power of k times 0 is equal to 1. And we move 100 into the left hand side and we get a equal to negative 75. After 1 minute, the temperature of metal bar increased 3 degrees Celsius, which means after when t equal to 1, then the t, which is the temperature of metal bar, is 28 degrees Celsius. So we substitute the number into the equation and we get 28 equal to 100 minus 75, which is a that we get before, times e to the power of k times 1. And we arrange the equation and we get 75 times e to the power of k equal to 100 minus 28 equal to 72. Next, we divide by 75 both sides and we get e to the power of k equal to 72 over 75 equal to 24 over 25. And we times long both sides and we get k equal to negative 0.04082. So, the final equation we get is t equal to 100 minus 75 times e to the power of negative 0.04082t. So, the question asks us to find the times when the metal bar increase to the 85 degrees Celsius. So, we substitute the value of temperature into our equation and we get 85 equal to 100 minus 75 times e to the power of negative 0.04082t. And we arrange the equation and we get 75 times e to the power of negative 0.04082t equal to 100 minus 85 equal to 15. And we divide by 75 both sides and we get e to the power of negative 0.04082t equal to 1 over 5. And then we times long both sides and we get negative 0.04082t equal to ln 1 over 5. And we divide by negative 0.04082 both sides and we get t equal to 39.4277. Then, the time required for the metal bar to reach 85 degrees Celsius is 39.43 minutes.
Question number 2. A tank contains 300 liters of fuel in which 20 grams of salt is dissolved. Brine containing 1 gram of salt per liter is pumped into at a rate of 5 liters per minute, and the well mixed solution is pumped out at the same rate. Find the amount A of t of grams of salt in the tank at time t. From this question, we can list down all the information given first, which is when time t equal to 0, the amount of salt is 20 grams. The volume of the tank is 300 liters. Next, we get the concentration of the salt in brine is 1 gram per liter, which the water flows into the tank is the rate of 5 liters per minute, denoted as dV over dt in. The water also flows out of the tank in the rate of 5 liters per minute, denoted as dV over dt out, means they are same. For solution, let the amount of grams of salt over the time t is dA over dt. dA over dt equals to the rate in of salt minus the rate out of salt. Let this be equation 1. First, let's calculate the rate in of salt first. Rate in of salt equal to the concentration of salt times rate of water flow, dV over dt in. The concentration is 1 and the rate is 5. Multiply equal to 5. Let this be equation 2. Second, the rate out of salt, that equal to concentration of salt times by the rate of water flows, dV over dt out. When solution was mixed, the concentration of the salt will change. So, we write as A of T over the volume of tank, which 300 liters, and the rate of water flows, dV over dt out is 5. By multiplying and simplify, we will get A of T over 60. We will write this as equation 3. Next, substitute equation 2 and 3 into equation 1. We will get dV over dt equal to 5 minus A of T over 60. In standard form, arrange is as dA over dt plus A of T over 60 equal 5. To solve this, we need to find the integrating factor, which is exponent to the power of integrating 1 over 60 dt equal to exponent to the power of t over 60. As we find the integrating factor, multiply it to the standard form equation to both sides like this. As we can see, we can factorize it as d over dt in the bracket of exponent to the power of t over 60 dot A of t equal 5 exponent to the power of t over 60. Then we cross multiply and integrate 5 exponent to the power of t over 60 to 5 dot 6 to 5.60 dot exponent to the power of t over 60 plus c, where c is the constant. Don't forget.
Now, to let A of T be the subject of the equation, we must
Dividing exponent to the power of t over 60 for the both sides. Then we will get A of t on the left hand side and 300 plus c exponent to the power of negative t over 60. We need to find c. So, to find c, substitute when t equal to 0 and the amount of salt equal to 20. Calculate it and we will get c equal to negative 280. Now, substitute c equal to negative 280 to this equation. Therefore, the amount of A of t of grams of salt in the tank at the time t is A of t equal to 300 minus 280 exponent to the power of negative t over 60. That's it. Thank you.